Hello everybody, very important lesson today. I can dilate lines by keeping the slope and substituting the center to determine if the y-intercept is the same or different. Whenever I dilate lines, the slope is always the same because the image is always parallel. And then to determine if the y-intercept is the same or different, we're substituting x and y, the center, into the equation. If it equals out, the y-intercept is the same, the line is the same. If it's not equal, if it's not on the line, then the y-intercept is different. So this is the third lesson that we've done within this little subtopic of line dilation. This is kind of putting everything together. And to help us with everything we need to know, we have our song. So let's hear our song. Let's go to Schlansky.com, YouTube, playlists, and geometry. And here we go.
Line dilation, parallel, keep it slow. Center on the lines of X and Y on the line. Same beat, off the line, different origin, multiply, scale factor, and beat.
Yeah. So let's kind of like put those notes out here so we have them to refer to. This lesson, I say this lesson, this group of lessons, there's a lot of little things to know, but if you know all those little things, then it really comes together pretty nicely. So for line dilations, the image is always parallel, which means you're going to always keep the slope. No matter what, if I'm dilating a line, the image is always parallel, so we're always going to keep the slope. Next, we want to determine if the center is on the line. To do that, we're going to sub x and y. So once we do that, if it's on the line, same b. If it's off the line, different b. And then the final circumstance, if it's origin, then we're just, you don't have to go through that procedure. You don't have to determine if the center is on the line. If it's origin, you're multiplying scale factor and b. So we'll refer back to these notes as we go through here. But again, what you need to know about line dilations, the image is always parallel, which means the slope is always the same. To determine if the y-intercept is the same or not, you have to determine if the center is on the line by subbing x and y. However, kind of separate from that, for origin, if it's centered at the origin, you don't have to go through this procedure. You can just multiply the scale factor in b, but you're still always keeping the slope. So there's a lot of different types of questions that you might see based on this. We're going to see all those different types of questions, but the majority of the questions that are asked are the ones that we're going to see towards the end of this packet. All right, let's do it. A line segment is dilated by a scale factor of 2 centered at a point not on the line segment. Which statement regarding the relationship is true? Line dilations, parallel, keep the slope. Line segments are perpendicular? No. Line segments are perpendicular? No. Line segments are parallel? Parallel? Yes. So at this point, just by knowing the first line of our song, it's got to be 3 or 4. If it's dilated by 2, is the image twice or half the length? If it's dilated by 2, it's getting bigger, it's twice the length. If it was dilated by a half, then it would be half. So the answer would be choice 3. So it's a conceptual question, there's no math to do, but it's about just understanding that all line dilations are parallel, which means their slopes are going to be the same, and then it's kind of your understanding of what a dilation is for the second piece of it. A line that passes through the points whose coordinates are 1, 1, and 5, 7 is dilated by a scale factor of 3. Line dilations parallel keep the slope. Boom. Now, it's possible that it could be the original line if the center is on the line. I would suggest using graph paper for this, which is, I guess, exactly what I should do if I'm telling you to do it. 1, 1, and 5, 7. So we've got 1, 1. We've got 5, 7. If I draw a line through these points, this isn't great to see from the graph, but it's close, but it does not pass through the origin. Being how the center was the origin, the center is not on the line, therefore it's going to be a different line. Oops. I don't know what I just did. I want you to try number 3 and 4 on your own right now. So please pause, try numbers 3 and 4, and then unpause. Okay, now that you tried numbers 3 and 4 on your own, let's go over them. The line whose equation is blah, blah, blah is dilated. Line dilations parallel keep the slope. Same slope, different slopes out. Same slope, different slope is out. So what are my options here? My options are different y-intercepts or same y-intercept. To determine that, center on the line sub x and y. My center is my origin, 0, 0. So I'm going to substitute 0 for x and 0 for y. And I'm going to see if this equation holds true. Well, 3 times 0 is 0. I'm a little scrunched here, but what else? 5 times 0 is 0. 0 minus 0 is 0. 0 is not equal to 4, so it's not on the line, which means my y-intercept is different. Same y-intercept, no. Choice 1 is my answer. The slope is always, always, always the same for line dilations. To determine if the y-intercept is the same or different, we sub x and y, our center of dilation, into the equation of the line. If it works out, then yes, it's on the line. It has the same y-intercept. It's the same line. If it's not on the line, it's a different y-intercept. It's a different line. I also asked you to do number 4. Dilation. We have lines going on here. So, line dilation, parallel keep the slope. It doesn't tell us what the scale factor is. It says the scale factor is k, which means I don't know what the exact scale factor is. So, do I know that 2 times AB is AD? No, I don't know that B is the midpoint. I don't know that the scale factor is 2, so I don't know that. I have no reason to believe that those are perpendicular. There's nothing that's telling me that. AC and CE are the same. Again, it doesn't say that it's the midpoint, but I do know that when I dilate a line, the image is always parallel. 5, I'll skip for now. I'll let you do that for homework. Number 6 is the next type of question that they ask. This comes up in the Regents, this exact type of question maybe once every 3 or 4. The line is dilated. Line dilations, parallel, keep the slope. I know that the slope must be the same. I don't know what the scale factor is, so I really can't tell you the exact equation, but I know that the slope has to be the same. So, what's the slope of my original line? I have to get y by itself in order to get the slope of my original line. Y equals negative 2/3 x plus 8/3. So the slope of my original line is negative 2/3. So, my answer must also have a slope of negative 2/3 because whenever I dilate a line, the image is parallel, the slope's the same. So I'm going to go through the choices. I have to get y by itself for each of them, so that's a little bit annoying, but it is what it is. So this was the very first lesson of the unit we did, getting into y equals mx plus b form. So if you're not comfortable with this, go back to that lesson, slope-intercept form. Y equals negative 2/3 x plus 5/3. This has a slope of negative 2/3. This has a slope of negative 2/3. They're parallel, therefore that could be the image. It's always a good idea to go through the rest of the choices. I'm not going to go through the rest of the choices now. So the concept, if I know that a line is being dilated, the image must be parallel, which means the slope must be the same. Being how all it's telling me is that it's being dilated, I don't have a scale factor. All I know is that the slope has to be the same. So I just have to find which choice has the same slope as my original line. Number 7 is the same type of thing. The line represented by the equation blah 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 is transformed with a dilation. Line dilation, parallel, keep the slope. I know that the answer must have the same slope as the original line. So I want you to pause this right now, get the slope of the original line by getting y by itself, get the slope of each choice by getting y by itself, and once you do that, you'll have your answer. You'll see which one's the same. So please pause, finish the problem on your own, and then unpause. Okay, the original problem, the original line, 4y equals 3x plus 7. I would divide by 4. The slope of this line is 3/4. So now I'm going to start going through each choice. Choice 1, 3x minus 4y equals 9. I subtract 3x. I then divide by negative 4. I get positive 3/4 because a negative over a negative is a positive, minus 9/4. 3/4, 3/4. I already have my answer. Again, it's a good idea to go through all 4 choices, but I'm not going to right now. 8's the same thing. Yes, no, no. 8 is not the same thing. Because now it's telling me the center, and it's giving me, actually, no, it's not. It is the same thing. So I mean, since all the slopes are different, then all I need to know is the slope. So, line dilation, parallel, keep the slope. Why don't you pause it, try and finish this problem on your own from here. Okay, now that you tried this question on your own from here, I need to know the slope of my original line. So whenever I'm isolating, I add or subtract first, and I divide last. The slope of this line is 2. I know I have to keep the slope whenever I'm dilating a line. Y is by itself already for each of them, so it's a little bit less work. All right, so now I think the whole rest of this really gets into, and again, all these questions I've given you are pretty much Regents questions. But now we really get into what comes up the most. Line dilation, parallel, keep the slope. No matter what, when I'm dilating a line, keep the slope. So take about 5 seconds right now and cross out 2 of the options. If the slope is negative 1/4, then the image must also have a slope of negative 1/4. Line dilations parallel, keep the slope. Now, from here, there's 2 circumstances. Origin or not origin. If it's origin, multiply scale factor and B. Origin's probably easier. You just have to recognize that it says origin and know what to do. If it's origin, your new y-intercept, you're going to multiply the scale factor and the original b. Your new y-intercept is going to be -8. Choice 1 is going to be your answer. If it wasn't origin, then you'd have to determine center on the line, sub x and y. So I'm going to flip back to the notes just so we see the different circumstances here. It's always parallel. You're always keeping the slope. So the slope's always going to be the same. So we have the slope. We're done with the slope. For the y-intercept, if it's centered at the origin, you're just multiplying the scale factor in b. That's all you're doing. If it's not the origin, then you have to determine if the center is on the line by substituting x and y. If it is on the line, then the b is the same. If it's not on the line, then it's different. A lot of little conceptual pieces, but once you have those little conceptual pieces, you're good. Line dilation, parallel, keep the slope. The slope is 3, so my answer must have a slope of 3. So that doesn't really help me here because all 4 choices have a slope of 3, but I know that the slope has to be the same. It's centered at 3, 8. It's not centered at the origin, so I'm not multiplying the scale factor in b. Center on the line, sub x and y. I'm going to substitute to center the x and the y into the equation. It works out. On the line, same b. It is right here. If it's on the line, it's the same b. I just showed it's on the line since the equation equals out. So, same b, -1, -1, choice 4. If the center of dilation is on the line, the equation is the same. The image is the same line as the original. So, again, 2 questions that look very similar, but they're different. No matter what, the slope is going to always be the same. If it's centered at the origin, you're multiplying the scale factor in b. If it's not the origin, we're substituting into the equation of the line. And if it equals out, if it's on the line, and the y-intercept, the b is exactly the same. I want you to try 11 and 12 on your own right now. So please pause, try 11 and 12 on your own, and then unpause. Okay. Line dilation, parallel, keep the slope. The slope has to stay. The slope is 2, so it has to be choices 1 and 2. Origin. Origin. Multiply scale factor and B. So, scale factor, original B. You can type that into your calculator if you need to. If you're not comfortable multiplying by a fraction, it's -6. Choice 2 is your answer. And number 12, line dilation, parallel, keep the slope. The slope of the original line is -3, so the slope of the new line has to be -3. Is this origin? No. Center on the line, sub x and y. So I'm taking my y equals -3x plus 6, and I'm substituting 0 for x and 6 for y. And it works out. The center is on the line. On the line. Same B. Same B, same M, same equation. If the center is on the line, it's the same. Now, you might be thinking, well, what if it's not the origin and it's not on the line? Well, we did that yesterday. That's where you'd have to use the graph to find the y-intercept, but usually they're just going to ask you something like this, where you're going to see if it's on the line, and you're going to say if it has the same y-intercept or a different y-intercept. They've never asked a question in the regions where it was not the origin, it was not on the line, and they asked for the equation. All you've been asked to do is something like this here, where if it's not on the line, it has a different y-intercept, so you're just stating that it has a different y-intercept. But that being said, we did do the lesson yesterday where we were able to find the exact equation. That's it. Actually, I'm sorry, is there one more I want to go over? 13 and 14, and all these are really the same. Let's take a quick look at 16. In fact, you know what? Why don't you look at 16 on your own? Try it on your own. I'll go over it, and then we'll call it a day with this, and I'll let you practice for the rest of the period. So just pause it, try number 16, and when you're done with it, unpause it. Okay. Line N is represented by the equation 3x plus 4y equals 20. Determine and state the equation of line P, the image of line N, line dilation. Line dilation, parallel, keep the slope, center on the line, sub x and y. If it was origin, I would multiply the scale factor in B. Since it's not the origin, I'm going to sub x and y. Now, many of you are thinking, well, I got to get y by itself. You don't have to get y by itself to sub x and y. So I'm going to replace the x with 4. I'm going to replace the y with 2. I don't have to get y by itself. You can get y by itself, but you don't have to. Yes, it's on the line. On the line. Same B, same M, same B. So what's the equation? What's the answer? The same line. You don't have to get y by itself even. That's it. Explain your answer. The center of dilation is on the line. So the equation is the same. Well, that was good timing. For line dilations, again, know your song. The song has everything in it. It's a topic that a lot of students have trouble getting these questions right in the Regents, but if you know this song, if you practice it, it's really not bad. Line dilations, parallel, keep the slope. The slope is always, 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 always the same. If it's centered at the origin, multiply scale factor in B. If it's not anything else, we're going to sub x and y to see if it's on the line. If it is on the line, the y-intercept's the same, the line's the same. Exactly. If it's not, then it's going to have the same slope, but a different y-intercept. Your classwork/homework is to finish this, and I hope everyone has a great day.